So today I'm going to demonstrate a network security monitoring package called Security Onion. Security Onion is something that has been around for a while. It's a compilation of a bunch of different things, and tECHO became involved with it because we had a client who one day asked us to try to help them understand why someone on their network had gotten them banned from Craigslist. So let me let me get to the point here where we can. Okay, so here we go. So Security Onion is basically it's a collection of open source tools, and it's a collection of open source tools that have been around for some time. It's going to allow you to quickly and expeditiously deploy an IDS, a log aggregator, all the things you would need to get a handle on what's happening on your network. It's going to allow you to do network security monitoring in an environment where you're not completely sure yet maybe what the value of security monitoring might be, or network security monitoring might be. The installation process is very straightforward. The open source community is great in that it's given us a wonderful set of tools. Most commercial tools are based on the things that you'll see in Security Onion. But Security Onion is a way to quickly get these things deployed and working in your environment without having to spend a great deal of time setting them all up. It's designed with people in mind who might have some experience dealing with Windows networks but might not be very proficient in Linux. I'm an example of that type of a network admin. I've been doing this job for around 25 years, but I'm much more. My strengths are much more in Windows than they are in Linux. It took us a total of about 30 minutes to deploy the solution, and about 4 hours to get it doing useful work for the client who needed to find out what was going on in their network and why their reputation was being damaged at Craigslist. So let's take a look at maybe some of the types of problems you might see when you deploy something to do network security monitoring. A lot of the strength in the package comes from the type of alerts that are triggered by it, and the alerts are going to trigger on things that might be broadly classified as acceptable use policy violations, evidence of mischief happening on the network that has to do with maybe there's malware running, maybe there are Trojans happening. You're gonna learn about your users' risky browsing behavior. There are a lot of different types of triggers that might set off this IDS. You're going to also see hacking attempts and evidence that something is going wrong on the network in terms of a compromised host. The bigger question probably is what exactly network security monitoring is. The biggest distinction between network security monitoring and the other types of security work you might do is that it has to do with looking at the network, not looking at the hosts. We all do the best job we can to configure our equipment not to be vulnerable to threats. But network security monitoring is kind of an acknowledgement that you're never really going to be completely successful. You can't assume that your best efforts to protect your network against things that might go wrong on it are going to be 100% successful 100% of the time. They won't be. So network security monitoring is a process that involves having a response team set up whose job it is to monitor the network for evidence of problems that are brewing or that are in progress right now. It's really important to underscore that this is a process. This is not deploying a box that's going to have a green light on it that says you're safe and a red light on it that says you're not. It's giving you visibility into your network and the ability to see when problems are coming up. The process of network security monitoring could be segregated into maybe two different halves. You probably have somebody who's responsible for your IT needs in your network. Maybe that's in-house IT. Maybe tECHO helps with that, but there's also a security role that might be somebody whose job it is only to watch the network and to engage the IT department when they see a sign that there's been an indicator of compromise. It is a process. It's not a it's not something that can be just, it's not a set and forget type of situation. You need to actually think of it as being something that's constantly going on in your network. And the goal of Security Onion is to make that job, 1, free, and 2, easy. So what kinds of visibility can you get? There's a lot of things you're going to learn about your network when you deploy this package. It ranges from being able to see full content. When you deploy this distribution, you are recording everything that goes across your network to disk. So it's going to be able to give you forensic capabilities. If something bad happens, you're going to be able to go back and see exactly what transpired. It's going to give you the ability, if you need to see extracted content from the data. An alert's great, but knowing whether the alert actually was meaningful oftentimes means going back to take a look at what actually happened in it. And so there are tools that exist here that allow you to quickly pivot to the raw data in the packet, to the objects that exist in the raw data. Session data is represented here. You're going to see logs that show you evidence of every time any 2 given hosts on the network connect, who they are, what they talked, when they talked, how much they talked. There are tools that'll log this data to this package. You're going to see transactions that happened. What was the content of the conversations? If 2 hosts connect, what do they talk about? You're going to see the transaction data as well in the logs here. Statistics. So statistics are useful. They're most useful when you know what a normal day in your network looks like. Statistics can tell you, for example, that, well, today is a bad day, and the reason that today is a bad day is because we've got a whole lot of inbound traffic that are tiny packets that look suspiciously like maybe a distributed denial of service attack. That's the kind of statistics you can get from this package. Metadata, data about data. This refers to the ability of these tools to be able to do things like lookup, who the individual computers are that are involved in conversation. Reverse DNS, who is, if you see that you've got a computer in your network that's talking to a bunch of hosts in China, it might be kind of useful to actually see who those IPs represent. You're going to see, and finally, I think the most useful thing that you're going to get in terms of visibility is alert data. So Security Onion, most people who come to this package, they get there because they've heard that there is a thing out there called Snort. It's a very popular intrusion detection system. There are competitors to it. They all revolve around having a community that is constantly evolving a library of definitions. When somebody sees something bad happen on their network, they look at the traffic, and they think about how we might be able to alert other users of this problem in the future if it happens. And so the alert data is it's available to you either free or on a subscription basis, and it's gonna be your first line of defense when it comes to have visibility into what's happening on your network. Maybe let's talk for a moment about what those intrusion detection sensors are. The 2 big ones are Snort and Suricata, and I got to say that Snort is probably the biggest of the 2. It's been around forever. It's been around since 1998. If you are interested in Snort, you should know that these days it's a Cisco acquisition. You can use Snort by virtue of simply signing up for it. You get a thing called an OINC code. The IDS environment is highly pig-centric in Cisco's universe. You can do it for free, or you can spend as much as up to $400 per sensor. What's worth mentioning here is what you get for paying for it. When you pay Cisco for Snort definitions rather than just getting them for free, what you're getting is you're getting newer ones. You're no longer waiting 30 days, and you're also getting access to a curated set of definitions that are the result of everyone in the open source community who uses them. That's great, but people who are paying for it, they have the ability to actually call Cisco and say, look, this one's falsing, and we think it falses for this reason. Can you help us with this one? So paid definition is going to result in less work for your department because there's going to be less noise and more signal. Suricata. So Suricata is almost 10 years newer, benefits from some advances in technology that have happened since then, but at the same time is not quite as well supported or stable. Suricata is capable of some interesting tricks. You get the choice of deploying either or one of these things when you deploy Security Onion. You're given a checkbox and you get to select which one. I would suggest that you save yourself some time on your first deployment of this package and select Snort, because although it's not as new a system as Suricata, it's much more stable. If you're going to subscribe to, if you embrace the Suricata platform, you're going to be talking to Proofpoint about getting paid subscriptions. Emerging Threats was acquired by Proofpoint in the last couple years here, maybe the last year. They're a little bit more expensive. They think their platform's capable of more. All right, so the having a sensor that's constantly watching your network is great, but how are you going to get any visibility into it? And this is where Security Onion probably really shines most. Snort's available in lots and lots and lots of commercial offerings. You'll see Snort as part of a lot of firewall manufacturers' distributions, but what makes it particularly useful is having a way to actually see what it's doing. And so there are two major systems that have evolved to allow you to get some visibility into what your IDS is going on in your IDS platform. One of them is the Squeal database, and the other is the Snorby database. Sorry for the names. Squeal has the advantage of having a web front end called Squirt. Again, yeah, it's hard to take these things seriously sometimes, but wait and see. Between these two platforms, I'm going to suggest that you look first at the combination of Squeal and Squirt. To somebody who's not done a lot of work with intrusion detection systems, the Squirt front end onto the Squeal database is really the first thing you probably, as a Security Onion, as an early adopter or a recent adopter, want to take a look at. It's the most useful, the easiest to get around in, and if you want to save yourself some time, the advice I would have for you is to deploy Security Onion, choose Snort, and primarily deal with Squirt, which is a window onto the Squeal database where all these events are being collected. By and large, I've got to say that in my investigations into this in the last month and a half or so, I have not found a lot that you can't do with Squeal and Squirt that you can do with Snorby. So look at Snorby. There's some nice dashboards, but I think you're probably going to find most of your work gets done in Squirt. All right, let's take a look at the kinds of things you can see. In the Squirt console. All right, so when I log into Squirt, what I'm looking at is I'm going to first show you the summary view. The summary view shows you all the things that have come into this platform. It wants me to log in again, so I'll do that. Let's take a look at the summary view first, because maybe it's the most interesting to people who are concerned with dashboards. So the summary view shows you quite a few different things. What we're looking at here is the top signatures that were detected by our IDS. And you're going to see things like, okay, well, we've a lot. Okay, here we go. Here's our geographic distribution. This is a heat map that kind of shows you what countries have been related to the traffic we've been seeing. Kind of surprising that Brazil represents a lot of traffic. Incidentally, I should to give you some color on this. This is an IDS that we've deployed here in Echo's office, and we are watching here a network that's what, David, maybe about 30 users. How many people we got in this office on a day-to-day basis? And this is about 2 weeks worth of information that we've gathered by watching our 30 megabit connection in this office, which averages about 5 megabits of traffic on a given day. So here are the top countries where the traffic comes from. Looks like we've got some traffic to Germany, the UK, Ireland, Romania. So Romania, why Romania? Bitdefender. It's all legit traffic. But if we wanted to, and we were concerned about it, what we could do is we could look at Romania. We could click on it, and you see what happens is it populates that search box up there. And now with that done, we can go back to our events view, and we can refresh it, and we can see what all the traffic to the country code of Romania is. And here it comes. All right, well, predictably, Bitdefender. So what I'd like to show you with this is that this is what the console, to the person whose responsibility it is to watch this system, this is what they're going to do every day. They're going to log into it, and they're going to go to this console, and they're going to see, they might look at the summary view, but they're more likely going to look at the real-time event view. And the real-time event view is going to show them all the things that have happened in this IDS that have yet to be classified or categorized as a real problem or no problem at all by a human being. IDSs are far, far from perfect. You need to expect a lot of noise. And the job of the person who sits there, who monitors, who manages this system is primarily to tune it to get rid of the noise and to escalate the things that they find happening here when they see something that represents a legitimate threat. So when you have a maybe your company might have already invested several $1,000s in a security operations center. The bulk of the money being spent when you do that is to hire somebody whose job it is to look at this console and make a decision about the things they see happening in it. So today I've logged into it, and well, what am I going to do? Okay, there's a ton of events happening here. This is a view that shows me only the last 24 hours. In fact, I'm going to go ahead and change this right now to make sure that we are looking at, in fact, 24 hours of data. I'll do it like that. Okay, now these are uncategorized yet events that show up in Squeal. I'm going to go ahead and say, okay, well, I'm overwhelmed by the number of events I see, so I'm going to select priority. I only want to see the high priority events, and maybe I'll attend to the medium and the low priority events later. If I click on high, well, it's going to show me the things that it considers, based on the definitions, what of these things are actually maybe high priority events. And then I'll dig through these things and I'll look at them on an individual basis. And when I look at these things to try to determine whether they're priority or not, let me show you how I do that. I'm going to look at some things I've already classified earlier so as not to waste a lot of time here. I'm going to go ahead and look at some of the things that I think probably represent compromised hosts. All right. Let's take a look at this. Well, okay, first of all, we have a violation here that looks like something is sending an unencrypted password. And what's this? Something's trying to download configuration from a Zyxel router, an attempt. All right, well, if I'm concerned about any of these things, what I'll do before I've classified them is I'll actually look at the queue by clicking on it over here. And then I'll drill down into it, and I'll look at the event, and I'll look for it, and I'll get a transcript of it. And right now what it's going to do is it's going to look at the packet capture that represents this event, and it's going to show me exactly who the conversation was between. Well, the attempt was to somebody in the Ukraine. That's probably a red flag. We don't do business with anybody there. Right. And this represents what the conversation looked like. This is being generated by a tool whose job it is to track this type of conversation anytime the IDS sends up an alert. So what I've done is I've categorized this particular event as maybe something I want to look into further. And so as a result, it's classified here in this count by classifications. It becomes the job of IT then to look at this particular host and determine whether there's something wrong with it. Because right now, I think there's something wrong with it, and I wouldn't have known if I didn't have the system running. You can determine all kinds of things, and I'm just going to give you a whirlwind tour of the types of problems you might find. Okay, compromise level 1, the most serious classification. Well, okay, blacklisted communications to blacklisted IPs. Blacklisted by who? You can drill down and figure if you want to. I won't bore you all with that. Compromise level 2. Well, this is this represents a bunch of conversations I saw happening with a client on our network trying to resolve a bunch of random host names. Why in the world would anyone try to do that? Well, tomorrow morning I'm going to find out because this user's been told they need to do a virus scan on their machine. You'll learn other things like policy violations. Just to give you an example. If somebody logs into a WordPress site and doesn't use SSL to do it, we find out about it. And we actually see the credentials they use to do it. And in this case, we've learned a couple of things. We've learned that we have a client that perhaps needs to secure their WordPress site better. There are other things you can determine as well. I've classified as things worth escalating. I don't know if I can see them in this view or not. That's not... I promise you it's not Vedran's workstation. We all have probably heard something in the recent past about the Poodle security vulnerability. If a communication happens between two hosts that involves SSL version 3, we find out about it. The bottom line is that these definitions that you're getting access to for free provide a shocking amount of visibility to the things that happen in your network. And if you're not quite sure whether it might be worthwhile to spend money for definition updates, deploying this is a quick way to find out that it might well be. Let's look at maybe another one of the things that this tool gives you. There is as distributed as part of the tool set, there is a log aggregator. Now let's say that you've spent a lot of money on fancy next generation firewalls. Maybe it includes, you know, you've bought Fortinet, you've bought Palo Alto, you've bought Cisco with FireSite. What are they doing for you exactly? Well, maybe you've bought their management platform and maybe you've got a console, but if you don't have it yet or you're evaluating it, this ELSA tool is a great destination for all of the log output that those firewalls might generate. And you're going to be able to see things in here like, well, okay, who are the top websites that my users browse to? Well, your IDS can tell you, and this system can tell. Yeah. It turns out that on this, yeah. So on this network, unsurprisingly, we have a lot of traffic to Bitdefender because that's who we use for antivirus. We have a lot of traffic to Windows Update, which we could probably eliminate if we were to get our Windows updates being done internally. And we have a whole lot of traffic, and this is true of virtually every network I look at. Apple is almost always at the top of the list of any network's traffic to the internet. You're going to be able to determine things like who your top talkers are, who uses SSH the most. You're going to be able to determine things like, well, let's take a look at the top alerts that we see here. The alerts that the IDS is generating, you can take a look and see, you can drill down further into any of these things. Who, for example, is the most, who commonly offends when it comes to Python URL lib suspicious? Well, you can see all of it here. If you want to do a packet capture, you can pivot to it from this tool. ELSA is a great way to take a lot of very difficult to classify log information and help you find the useful stuff in it quickly. I won't spend too much more time in ELSA. There's a lot more time I could spend in it, but you can see the types of built-in searches that ELSA is able to do. You can point a lot of stuff at your Security Onion server that wants to send log output out and get a much better handle on what kind of traffic is being generated using this tool. I will take a moment to look at the Snorby dashboard because it is a prettier dashboard than many. Snorby is able to do things like tell you, give you a graph that shows you how much traffic that has been generating alerts in your network in the last 24 hours, last week. The thing that I need to underscore with Snorby though is that the database that it uses has no relation to the other one. Everything that goes on in Snorby stays within Snorby. So if you spend a lot of time classifying events in Snorby, it won't be useful in the other one. I would recommend for that reason that you start with the other one. That is the whirlwind tour of Security Onion's deployment. Now I want to talk about some of the things that are going to come up when you first try to deploy this. It's very, very easy to deploy this distribution. It takes the form of an ISO image that you download from the internet. You're going to install it either on physical or on virtual hardware. It's smart enough to be well supported if you try to run it under VMware. You should assume that you're going to use at least 4 cores and 8 gigs of memory. You also, the first question that comes up is if I'm writing all this storage, if I'm writing all this information to disk, how much disk space do I really need? What you really need to do is you need to have a sense of what your average throughput on your network is, multiply it by, I would suggest, 30 days, add to it 2% for your database and 1% for your logs. For us, that means we need about a little over 1.5 terabytes to give us 30 days of history on a network that's 30 megabits and about 5 megabits in throughput average. The other thing that I need to mention is so an IDS, whether it be Security Onion or your firewall, anything, where are you going to put this sensor? Some people's first reaction will be, well, I'm going to put the sensor between my firewall and the internet. That will be not very useful to you. That's going to show you a bunch of conversations between your firewall and the internet, and that's not really what you're after. What you're after is you're looking for conversations between the hosts on your inside of your network and the internet, and as ushered through by the firewall. So I would say that the most valuable place to put your first sensor is going to be on the inside, and you probably want to have it be a mirror of the port that uplinks to your firewall. This is pretty easily accomplished on Cisco switches. They call it a span port. Everybody else calls it a port mirror, but the bottom line is that you will find that a modestly capable 4-core deployment of Security Onion can easily watch a very fast network with 1 thread. It's very efficient. When you install it, you're going to be looking at a console. It's a graphical installation process. It's a very straightforward process. I would recommend you take all the defaults. Uh, when you get done with it, though, before you turn it on, I would recommend you take a look at a close look at two variables: what your home networks are and what the external networks are. And the external networks is usually just what your home networks are not. If you don't define these two things, you're going to find yourself watching a lot of traffic that you don't care about. One of the things that I think is most important when you deploy an IDS or either Security Onion's or anybody else's is that you think very critically about how do I decrease the footprint of the networks that I'm monitoring. You do not want to be monitoring all the traffic that happens between your employees' iPhones and the internet. Absolutely not. You want to be segregating that off into a guest network so that you don't have to worry about it. If the guest network can't talk to your protected assets on the inside, you need do nothing to think about all those communications, and this will be very critical to you at some point in the near future. So have a good guest network, and I think I've got a blog post that's going to go up shortly about that. Configuration tips that I might offer that I haven't already talked about. You're going to get asked questions about whose definitions you want to use when you first deploy this thing. My recommendation would be that you take the 5 minutes it takes to go to Snort's website, sign up and get an OINC code, and then tell it to use this particular rule set, the Snort VRT and the emerging threat no GPL definitions. That's a great starting point. It won't fill you up with noise. It's a fairly reliable rule set. For people who have not deployed Linux servers and who are wondering how they're going to get console access to a Linux server, my recommendation here would be that you install a tool called XRDP. What this will let you do is it will let you connect to a Linux server with remote desktop protocol, as though it were a remote desktop services running on a Windows server. It's a lot easier. The closing configuration tips would be that this is, at its core, this whole thing revolves around a couple of MySQL databases, and at some point you would probably like to be able to look at them without having to know the MySQL command line. Having the workbench installed makes that a lot easier. This job becomes, after you deploy it, all about tuning, and here the important thing that I need to stress is that you not look at these alerts and think, I never want to see that alert again. Now, you probably do want to see that alert again, but you probably don't want to see it under the context you just saw it in. So I would recommend that as you adjust, as you tune this thing, that you think first about changing the thresholds, and only if you look at a rule and decide, you know what, this is bogus, I never want to see it again, only then do you disable it. Much better to say I want to change the threshold so that I don't see this rule fire under these circumstances than say I never want to see this rule fire again. You probably do want to see it again. I'm going to make sure that we all have access to this list. Some of the things I found most useful as I've deployed it are going to be some of these web references. I think at the end of the day, if you deploy it with that particular with Snort rather than Suricata and using that particular set of rules, and you know how much traffic you're going to generate and how much disk it's going to require, I think you'll quickly find within half a day's time that you're going to generate significant value with this thing, and at least you're going to probably realize why you might want to continue to do this. If not with Security Onion, then maybe with some other package. It's a great way to determine the value of doing network security monitoring in the first place, and I would strongly recommend you take a look at it if you haven't yet. Won't take much time. If there are any questions, I would love to talk to you about them.
So multiple sensors. Can you also put sensors with remote fire?
Absolutely.